Hello and welcome everyone. I'm so glad to have you here. Today we begin our journey through the class 11 mathematics course, an exciting step forward in your learning path. And we are starting with one of the most fundamental topics, sets. In everyday's life, we often speak of collection of objects of a particular kind, such as such as a pack of cards, a crowd of peoples, a cricket team, etc. In mathematics also we come across collections, for example, of natural number, points, prime numbers, etc. More especially, we examine the following collections. The natural numbers less than 10, that is 1, 3, 5, 7 and 9. The rivers of India, the vowels in the English alphabets, namely A, E, I, O, U, various kinds of triangle, the prime factors of 210, namely 2, 3, 5, and 7, the solution of the equations x square minus 5x plus 6 is equal to 0 are 2 and 3. We note that of the above examples is well defined collection of objects in the sense that we can definitely decide whether a particular objects belong to the given collections or not. For examples, we can say that river Nile does not belongs to the collection of rivers of India. As we know, this is one of the river of Africa. On the other hand, the Ganga does belongs to this collection. Again, the collection of five most renowned mathematicians of the world is not well defined because the criteria for determining a mathematician as most renowned may vary from person to person. Thus, it is not well defined collections. So there, so a set is a well defined collection of objects. The another name of objects are elements and the members. The sets are usually denoted by the capital letters A, B, C, X, Y, and Z, etc. The elements of these sets are represented by small letters A, B, C, X, Y, and Z, etc. An element A, if it belongs to the set capital A, we we can denote this by A belongs to capital A. This symbol is of Greek. This is a Greek symbol called epsilon. If B does not belongs to the set A, then we can write it as B does not belongs to A. Thus, in the set V of vowels in the English alphabet, we know the set of vowels of English alphabets, we can represent it if we are writing it as V. What are the English vowels of English alphabet? A, E, I, O, U. From this sets, one can clearly write that A belongs to this sets, but B does not belongs to this sets. Similarly, if P is a prime set of prime factors of 30, we can write the elements of the P as, what are the prime factors of 30? 2, 3, and 5. Therefore, if somebody asks you whether 3 belongs to this set or not, yes, 3 belongs to this set, being the element of this set. And what about 15? We can write 15 does not belongs to this set P. Further, we can represent the set by two methods. One of the method is the roster form, or the another name is tabular form, and second method is your set builder form. Roster builder form. In roster builder form, we can write the elements of the sets within the braces separated by commas. For example, if we have to write the set of natural numbers which divide 42, firstly do find the elements which divides 42. The elements or numbers which divides 42 are 1, 2, 3, 6, 7, 14, 21, and 42. So when we have to write the numbers within the set, we can write the numbers within the braces separated by commas. And moreover, one should note over here that the elements, order of the elements in the set is immaterial. Means we can write the elements randomly in the braces. For examples, I can write 1, 3, 7, 21, 2, 6, 14, and 42. The set of vowels in English alphabets are A, E, I, O, U. A, E, I, O, U. We can write the vowels within the braces. This is the roster or tabular representation of the set of vowels in English alphabet. Similarly, if we have to write the set of odd natural numbers, we can write it as 1, 3, 5. The dotted lines over here tells us that the list of odd numbers continue indefinitely. One should note over here that writing the set in the roster form, an element is not generally repeated. While writing the sets in the roster form, an element is not generally repeated. That is, all the elements are taken as distinct. For example, the set of letters forming the word school is S, C, H, O, L. There is no need to repeat the letter O twice, or even here the order of listing element has no relevance. We can write H, O, L, C, S. We can write the elements in any random order. The second form is your set builder form. In set builder form, all the elements of a set possesses a single common property which is not possessed by any element outside the set. For example, in the set A, E, I, O, U, for all the elements possesses a common property, namely each of them is a vowel in the English alphabet, and no other letters possesses this property. Denoting this set by V, we write V is equal to what? X separated by colon. X is the vowel in the English alphabet. Similarly, if A is a set of natural numbers that lies between 3 and 10. We can write it as within the braces x colon x is natural number and another property is x lies between 3 and 10. So one can easily find that the elements which will lie in the sets are 4, 5, 6, 7, 8 and 9 and at 9. If we denote the sets described in the above examples A, B, C in the roster form, we can simply write A is a set of all elements X. Which property it should satisfy? X is a natural number which divides 42. Similarly, if B is a set of vowels in the English alphabet, we can write it as V separated by colon. Write the property over here. V is a vowel of English alphabet. C as Z. Z is an odd natural number. Now let us do few examples. Example number 1, write the solution set of the equation. Our equation is x square. Equation is x square minus plus x minus 2x is equal to 0. Firstly, we need to find the solution of this equation. The nature of this equation is quadratic. One can easily find the roots of this equation by finding the number whose sum is 1 and multiplication is minus 2. We can write it as x square plus 2x minus x minus 2 is equal to 0 as a factor. So x is common from here. X plus we can write it as 2 minus 1. X plus 2 is equal to 0. So further we can write it as x minus 1 into x plus 2 is equal to 0. From here, what are the roots? x is equal to 1 and minus 2 are the roots of the equation number 1. So therefore the roster form of the set is, solution set is, we can write simply as within the curly brackets the solutions of this sets are 1 and minus 2. So the roster form of the solution set is given by this form. I hope the problem is clear to you all. The second example is, write the set x. X is a positive integer and there is another condition that x square should be strictly less than 40. Firstly, do find all the positive integer whose square is less than 40. We can start with, if we consider square of 1 is less than 40. Another, what about the square of 2? Square of 2 is 4, which is also less than 40. Square of 3, this is 9, this is also less than 40. 4 square, this is also 16, which is less than 40. 5 square, which is 25, this is also less than 40. 6 square, this is 36, less than 40. When you will move beyond this, this is 49, which is not less than 40. And therefore the solution set for this set is in the roster form. We will write all those integers whose square is less than 40, starting from the first. 1 is the 1 will be in this roster form, 2 will be in this roster form, 3 is in this roster form, 4 is in this roster form, 5 is in this roster form, 6 is in this roster form. So the set satisfying this property, which property? X is a positive integer and the square of x should be less than 40, will be 1, 2, 3, 4, 5 and 6. Another problem, write the set A. The set, now the given set is in the roster form. We have to write the set in set builder form. Now firstly let's check the property of this set. If you will look at the first element, can we represent it as 1 square? Another element is your 2 square. Third element is 9, which can be written as 3 square. Fourth element is 16, which can be written as your 4 square. Now, another element is 25, which can be written as 5 square, and so on. One can clearly check over here that every element is the square of the natural number. If it is the square of the natural number, therefore in the set builder form we can write it as a collection. First is x, then we should consider the second element. We should consider the properties of the elements. What is the property of the elements here? Property of the element is x is the square of a natural, x is the square of a natural number. This is the set builder representation of the given set, which is in the roster form. I hope the concept of set is clear to you all. We will discuss another problems in the next lecture. Thank you so much for watching this video.